All right, welcome everybody to week 3, day 1 of IS50B. I didn't upload Friday's lecture because I exposed personal information on the video and I didn't really want to update it or edit the video. But we didn't talk about too much that's worth recording anyway. We talked about the projects mostly. I'll go over wavelets again today. I will go over your proposal here. I think the mod idea is good. Basically, horde mode for Fallout 4. It's a cool idea. Yeah, sounds like fun. In fact, one of the things that I didn't like about the game was that you spent all this effort and energy and resources into building up your base, and then it like gets attacked twice in 200 hours or something like that. Like it really doesn't get attacked that often, and when it does, it's kind of a letdown. You've never played Fallout, so are you gonna buy it, or are you just gonna let the other guys carry you for the whole thing? Because that's not exactly a group project if you're not working on it at all, you know. I wonder how much it is these days anyway. Snap this over here. Scaling's like really weird on my computer right now. $20. Yeah, that's not bad. I've got a different monitor set up today. I returned my 4K TV because it wasn't doing 120 hertz well. It added noise to the screen, which is maybe okay if you're watching videos or whatever, but you know, if you have text and the line isn't straight, like that's just a deal breaker for me. I'll play today and tomorrow and work for sure. Can't let my teammates alone. Okay, cool. Yeah, I think it's a great mod idea. I think that's really cool. Make sure you get the GEC or whatever it's called. That's what it was called for Fallout 3. I don't know if it's the same name for Fallout 4. Let's see if it's got the same name. GEC editor. What's it called for Fallout 4? Creation Kit. Okay. Isn't that the CK in GEC? Okay, I don't know. Alright, so last played 2015. Yeah, that's fair. Yeah, where did my Steam go? That was last Fallout 4. That was the last time I played it. I was born on January 1st. Look at that. Isn't that amazing? 1950, huh? Sure. Downvoted. Yeah, that's a fair. I played 160 hours. Last played on 2017. Yeah. Yep, that's fair. Yeah, it's definitely a disappointment. Bethesda's really been going downhill with every game they make. So there you go. So this is the page for the creation kit. There you go. And good luck. As with everything, you want to start small and then work your way up from there. So, as far as like doing horde mode like this, start by spawning one monster, and then make it so that you can talk to Codsworth and spawn a monster with a repeatable dialogue option, and just kind of work your way up from there. For Unreal 4, an interactive level in the first person, utilizing materials to show off RTX lighting, dynamic lighting, etc. So, what kinds of things show off RTX? It's a bit of a rhetorical question, but I'm posing it to you guys. A room? No. You can do rooms using traditional rasterization, right? So, a nice room with windows, like the demo level. I mean, all that stuff you can do with rasterization. What RTX lighting really shows off well, I guess I'll just I guess I'll launch the technology showcase again, and hopefully it'll appear on the right monitor. There we go. Because this was on the Friday lecture that I didn't upload. Mirror Funhouse, yeah, Mirror Fun. Oh, there we go. Like, why would it not do 4K on? Okay, that's weird. Okay, so 2160 4K resolution. There we go. It was only doing 1080p on Friday. It's so weird. Okay, so Global illumination is definitely a benefit of RTX. All that light coming from the windows should add bounce lighting and ambient lighting to the room. And so global illumination is one of those really neat effects where you don't have any direct light on it. This would be direct lit. This looks a lot nicer. Global illumination is a nice effect. Ray trace translucency. So got these jars here. You turn them off. This is just a standard way of doing translucency. A ray trace translucency, it's actually bending the light rays as it goes through it. Ray trace reflections. So the time of day back to dawn. So over here, you can see that this thing here is picking up reflections from all over the place. And without it, it probably does a sphere capture. So it takes a screenshot of the world around it and kind of projects it onto the sphere. With that, it's actually going to update in real time the world around it. Reflections typically look pretty garbage without ray tracing. Like, interesting. What they typically do is they'll take an object like that and they will warp it onto the mirror surface. It's interesting. You could do the player. It's kind of odd that they wouldn't. That's a neat little artifact there, huh? This looks terrible. Yeah, and you'll get these weird artifacts like that as well without it. And so I think highlighting something and with ray trace reflections is actually casting photons and bouncing them and seeing what hits. And so you can actually see things like, you know, realistically without having to do these like little cheap tricks and things like that. So ray trace reflections off. You can see it's quite different. And in fact, with it off, it's just wrong, right? It's just completely wrong with it off. All right, so having a game, if you're going to do an FPS, having a game that uses ray trace reflections, I think would be really nice. Like if you have mirrors and like you can use those tactically. Like I've long wanted to make a game where you can like shoot lasers off walls, you know? And so like a game in which you've got, I don't know, maybe not a complete hall of mirrors because that gets very disorienting, but like some reflective surfaces, and so you can shoot something in. If you guys remember in Unreal Engine, you can do a trace line, and then when you hit something, there's a normal vector, and so you can reflect the trace line around that and do a second trace line, and when you hit something, reflect it and maybe do a third one. And so maybe like it's like a chain lightning gun that shoots and bounces and bounces. And so like it would be really interesting to have a tactical game where you can like shoot monsters around corners and things like that. And with RTX reflections on, you can actually see around corners. Whereas with the default thing, you can't. It won't see how it doesn't like pick up anything. It's a screen space reflection there. So when the ball goes off the screen, it's not drawn. And so if you cull something, like there's something called frustum culling, right? Where you've got the frustum, the view frustum, everything that's off the top, left, right, bottom, near and far planes gets cut away. And so when you only do screen space reflections, it will only do reflections for things on the screen. And so it'll draw there, but if I move the camera in such a way that it gets clipped like that, then it well, that's an even worse effect. It's like cutting out it's cutting the floor, but not the object. That's quite odd. So when you do screen space reflections, you literally can't shoot things around a corner because they're not visible. They're cold, and so you can't see them. But with RTX reflections, you'd be able to see monsters around a corner. And you don't have to do that, by the way. I'm just throwing out ideas. Like, if you wanted to showcase RTX, like, make it tactically interesting. Maybe, like, if, was it the Five Nights at Freddy's series, where, like, there's things chasing you or something. Maybe you can see them around corners, and you can use that to stealth or whatever. That could be really interesting, too. Ray trace it, then it looks a lot better. Direct illumination. You can see that the denoiser working there. So this is a typical shadow volume. So you've got a light, and it projects a shadow volume over the ground, and it's creating a shadow map. And the shadow map is basically the shadow volume where it intersects the floor. With direct illumination, it casts photons out, and these things bounce around and stuff like that, so you get much softer shadows, more realistic looking shadows than before. Alright, so you can see the shadows here, and then when you turn it on, you can see the denoiser at work. So the denoiser works over time to kind of accumulate information about a frame. And so if you actually look at the output of these ray trace things, a lot of times they only send like one photon per frame. And so what they do is they kind of accumulate information over time. And so if there's a fast change like that, you'll see it's actually quite noisy at the beginning, and then the denoiser sort of filters out the noise, and it looks pretty good. And so as long as you're not turning it on and off, like it looks all right. Or if you change, see, there's a little bit of noise in that. Let's see. We change the time of day. You can see the denoiser kicks in there as well. It's not too bad. It's not too bad. And as graphics cards get faster, you'll be able to kick up the detail on that. Now DLSS, I didn't explain it quite right on Friday. What DLSS is it actually will render the game at 1080p. I'm rendering right now at 4K, and it renders it at 1080p, and then uses an AI neural net to upscale the image. Let's see. It's currently running at, my face is covering up, but it's currently running at 65 frames a second. And if I turn it off, it drops to 26 frames a second. So it's like a 3 times speed increase. And you can really feel the game struggling with it off. And this is because DLSS is rendering literally a quarter the number of pixels on the screen. And it has a rather clever neural net trained to upscale it to 4K dynamically. And honestly, if you look at it, like, this is DLSS on, okay, DLSS off. It's really, like, I honestly, like, this is supposed to be 4K resolution. You can still see the noise on the pixels. Yeah, the noise is a little bit worse with DLSS on, I guess. Those moving straight lines are a little bit worse. See how it filters it. They've got it designed so that it tries to recreate straight lines as much as possible. So you can see when you sit there for a little bit, like, her hair comes in a little better. With it off, yeah, the effect isn't as pronounced, I think. So yeah, but basically DLSS means you are rendering a 4K scene in 1080p and then upscaling it. And I guess it's a little more blurry. It does a pretty good job. I mean, it triples your frame rate. So, you know, if you have trouble seeing the difference, that's definitely a win in my book. Okay, yeah, so I'm getting 65 frames a second with all the options turned on, DLSS turned on. That's not bad. With everything turned on, let's see, RTX off. RTX off. Then I am getting 45 frames a second. 80, 90, depends which part of the scene I'm looking at, 120. Because right now it's doing frustum culling, right? So all that stuff is behind me. It's all being discarded. Whereas at 160 frames a second, nice, nice, nice. If I spin around and see the whole thing, then the frame rate dips dramatically, right? And this is one of the downsides to rasterization, is that even with all of our very clever, occlusion, algorithms, sometimes you just got to draw everything. And if you got a lot of stuff in the scene, you can see the frame rate dip like this. So we're in the 40s to 50s, but if I'm up against the edge of the world, then frame rate skyrockets 100, 120, 130. Now if I turn RTX on, one of the reasons why RTX can be done these days is because it actually has the whole scene here in memory, and it's got a BVH for the entire scene in memory, and so it's actually still doing stuff from behind me. So if I shoot a light cannon here, and they're behind me, it's still drawing them, it's still rendering them, and these things are still picking up bounce lighting from these objects behind me. And so you can see the frame rate doesn't go up as high, but at the same time the frame rate doesn't dip as low either. And the reason for that is because it doesn't need to do the overdraw. With rasterization, it'll keep drawing the same pixels over and over again on the scene. If you've got 10 objects in the center of the scene there, all in front of each other, it'll overdraw them 10 times. Whereas with ray tracing, it just does that BVH lookup, and it just, whatever the first thing you hit, it's the first thing you hit. And so you can see I'm actually getting better performance with all the options on. With all the options on, I'm getting better performance than with a traditional renderer, which is nice. I'm getting less over here, right, because it still has things behind me to worry about, right? But it's still, not bad. It's really not bad. And of course that's with DLSS on, so if I turn that off and I'm doing an actual 4K rendering, I'm getting about half the speed. But look at the couch, right? This is full 4K resolution here, right? And if I turn DLSS on, I don't know. I honestly can't see any drop in resolution. Now you guys at home, you're in 1080p streaming, so I guess you have to take my word for it. But over here, there's a texture pattern on the blanket, and with DLSS off, I don't know. I'm legitimately not seeing any loss of detail in this bit over here. Or if there is, it's really, really subtle. And so, if you can't see something, you might as well do it. So it's a pretty fantastic feature. So the things that you could use in your game without RTX looks like the Source 2 engine. Yeah. Yeah. That screen space reflection. It's fantastic. So things that you could do to highlight RTX. Like I said, mirrors around corners, things like that for tactical thing. Global illumination. If you want to have indirect lighting like this, like windows and stuff, with the room being globally lit like this, it's not a bad look. Not a bad look at all. Yeah, translucency also. If you had realistic water, or if you had glass, thick glass with a Fresnel effect, you can see it in real time. See how it's bending, the light photons are bending through that. Pretty cool. Whereas if, oops. Whereas if you have ray trace reflections turned off, oh, that's translucent 0. There you go. Yeah, so maybe things like glass, water, yeah, those are all things that would highlight it. So that's, you know, a traditional rendering method there, projecting the shadow volume on the wall. With ray tracing, though, the shadows vanish, which is kind of interesting to me. Or they're a lot softer. Yeah. Okay, so that is that. The RTX Technology Showcase, the project files are available on the NVIDIA website. So you can download those and use that as a starting point. Yeah. Or you can use like the first-person shooter or something like that. If you're going to be doing, check the reminding proposition for Unreal Engine. So if you're going to do this, yeah, you probably have enough skills to place objects in the world. Today in 50A, I talked about how to use a use key. You can probably bind a key to like put a wall in the world in front of you, something like that. The tricky bit is going to be the AI, and so I would have somebody like learn the AI. There is a long demo you can do to go through on that. U4 AI perception system. I've debated teaching this. Is there an add-on for it? It might be an add-on. But basically, you have to set up a blackboard. There's like a lot of steps you need to go through. You need to set up a nav mesh. And so the nav mesh is nice. It'll update automatically if you put blocking train in there. But the whoever it is that does the AI is going to be like, all right, if I can't navigate to a player, then I need to find the nearest breakable barricade and like start destroying it or something like that. And so the AI perception system has the ability to add sight and sound and touch to an AI, and you can basically give them hearing and have a hearing range, and then you can have the player, when he walks around, generate footsteps, and the footsteps can trigger the zombie, like, there's a player over here, and try and navigate to them. So you can see things, and yeah, and then you can have events tied to them, and there's nav blueprints where you can navigate to the point. So going through this, and there's video tutorials on it as well. I think one of you guys should pick, like, that person should be the AI person, because it's a lot to go through. As far as like sharing, if the four of you are going to be working together on it, then you're going to need to do you're going to need to set up a repository. And not that one, not that one, not that one. I've seen students use Git before. What is the one they use? It's called like source safe, I think. Perforce. Okay, so that's the one that works best from what my students have reported. I always work on it by myself, or I just set up a Dropbox and copy files. But yeah, so you're gonna want to set one of these up. Yeah, can you share the link? Yes. There. You're gonna want to shut that up. Set that up. I've used Dropbox before, and the trouble is like when you can copy assets from one computer to another, like it breaks the links and things like that, and it's like super annoying to work with. So the official supported way of actually having a shared remote work environment is Perforce, and I never recommended it before because Perforce I always thought was a for professional, like you had to pay for it, but apparently there is a free version. So I double check on that. Try for free, free for small teams. Okay. Yeah. So it's got. So one of you guys should probably go through this. And so one person should do the AI. One person should set up source control first. You're not going to be permanently the source control guy, but that's a good experience for you too, because you know the world, especially now that we're all working remotely, learning how to set up a source control system. I use SVN as well. Interesting. I used SVN a long time ago. I haven't touched it in a long time. But it's free, so there's that. I would probably start with Perforce because that's kind of the recommended source control. GitHub, oddly enough, isn't really supported as well. So that's my recommendation. One of you guys should now go through it because you need that done before anything else can be done on it. Source control AI map, yeah, somebody's going to need to work on the player being able to build barricades and things like that. The AI person should be a person though, because it's going to take a while to go through the demo for it. And then you're going to need, I don't know, weapons or score, HUD, all that kind of stuff. Yeah, you have your experience in AI. Cool. Yeah. But get this done first. Like this is this is the blocking step. Like if this isn't done, you're not, like, it's going to be super annoying. Like one person will email the AI or Dropbox the AI to somebody, and then you import it and everything breaks because it's referring to things that don't exist. Yeah, so get that going. Like ASAP. You got to get that done before anything else. As far as Fallout 4, I don't know how to do source control on that, honestly. So you probably want to figure that out. Plenty of harsh days coming. Yeah, it's really good for you though. Like I always hated having professors say that to me. It's good for you, but it really is. Like yeah. Like source control is like kind of super incredibly important these days, you know. So you just Dropbox an ASP file, yeah, that'll work. I don't know, you can't really work collaboratively on it. Yeah, so somebody will need to do the map. Like I said, if you're going to be showing off RTX, then you'll need to make sure you have lots of lighting, transparency, reflections, things like that. And try to use what I'm looking for is for you to use them in a tactically interesting way, like not just like, oh, it's nice graphics, but actually have it tie into the gameplay. You know what I mean? Like being able to shoot zombie around corners, or at least see zombies around corners, things like that. Or you know, there's a swimming pool and the zombies are coming up out of the swimming pool, or there's thick glass walls and you can see them on the other side. And that controls your tactical decisions, things like that. Okay. How much of an external source can we use? Like if we can find a warehouse all set with RTX stuff. I mean, yeah, you can do that as a starting place, but you know, like I said, the game needs to not just use RTX for graphics, but I want you to see it incorporated into the core game mechanics. Okay. Yeah, if you find some free assets, by all means, yeah, go for it. Realistic rear view mirrors, yeah. I mean, that's how Battlefield 5 used RTX, right? And it was actually kind of terrible how they implemented it. like it would just bug out, like it would just stop working and it'd just be a blur or something like that. Okay. So yeah, I like your project idea. Let me go over wavelets one more time because I talked about that on Friday and ended up not uploading the video. So one of the reasons why wavelet image compression is better than JPEG image compression is because it works on edges. JPEG has what are called JPEG artifacts. JPEG uses an algorithm called discrete cosine transform, and discrete cosine transform breaks your image into chunks of pixels, and then it does a cosine trying to match the changes in colors. And the more cosine waves it adds together, the better the quality, but also the more data you have to write down. So low quality JPEG will use just a few cosine waves to represent each block of pixels. So what happens is that anytime you have a discontinuity, anytime you have an edge, you'll get a ringing effect around that. That's because it's using a cosine to represent the edge of the A, but then the cosine's an infinite length. Well, it's not. It's bounded by the size of the block. But what happens is that you get a gray area, and then you get a red area again, a few pixels past it. And so DCT JPEG works all right on natural things where you've got like smoothly transitioning grass colors and things like that. Anytime you have an edge, though, you see this. There's like a red pixel over here now. So all the red's down here, but it picked up a red pixel because it's a cosine, you know. And so it went down and goes back up, and boom, there you go. So over here you can see all the you can see all the hazing around the edges. And so it's actually, JPEG's actually kind of a garbage algorithm. And wavelets have been around for a long time, but I don't know why they haven't caught on as much. Like I worked for the UCSC Electrical Engineering Department doing a wavelet video compression algorithm for the military, and it looks nice and fairly pretty low bit rate, you know, if you want it to be. And the way that it works is you do edge detection. And so your last homework assignment was edge detection, and this is another case where edge detection is useful. And so what a wavelet transform is, it takes the original image, which looks like this, Castle Liechtenstein, and it divides it into 4 corners, and you can recursively do it. Here it's been done twice total. And the top left corner gets a downsampled version of the image. Simple. It's been done twice. This is a quarter of the original size. And then this part here is a horizontal edge filter. So what it does is it goes pixel by pixel, and it writes down the difference in color from one pixel to the next. So all the areas that are gray, it's gray to the right, gray to the right, writes down nothing. And then it writes down a high value, because when it transitions from gray to white, that's an edge. And so what you see here is, like on the staircase step pattern on the castle, you see all the vertical lines here, because as it goes horizontally, it finds all the discontinuities that way. This is the same thing, except it's a vertical edge detection algorithm, so you can see all the horizontal lines in the stair step. The top of the tower up here is picked up, because as you go down, it just differences each pixel's intensity from the one before. It's grayscale, and so it's just intensity, how white it is. And so you've got a horizontal line there, horizontal lines here, and then this is a 45-degree angle edge detection. And so if you want to recreate the image, you can transmit this, and you can actually get a preview. You can actually do a progressive JPEG scan, you know, like when it loads in at low resolution, and it loads in at medium, and it loads in at high. You actually get that for free here, because you can send this first, then this part, then this part. And so you can see a preview while it's loading, and then have the details filter in. But more commonly, what you'll do is you'll throw away this part here, and that'll give you a 75% compression, and you just transmit this part here. And it can recreate pretty well without human visible artifacts, because you've got the edge information in there. And human eyes are most sensitive to edges. We don't really see all the variance in color here. We definitely see where it goes from hair to forehead, right? That's an edge, that's an edge, that's an edge. And so those have to be preserved for the human eye to be happy, to say, yeah, that's, you know, you got the painting behind me. That edge has to be preserved. If it's blurred and ringing like the artifacts do on JPEG, it just looks terrible. And so wavelets via it's just a downsample, and it's actually pretty easy to write. Like the code for it was not complicated, and they actually hired me to port it from C++ to C, which is kind of a weird thing. But the digital signal processor they were using on the hardware side only worked in C, and so it's like, all right, yeah, sure, I can do that. It's really not a hard algorithm. How multiplayer works in Unreal. If somebody wants to do that, look up replication. So if you want, you can just turn on the replication box and see if it works, but it won't. Because for something that kind of looks simple, it's actually complicated. What you want to do is look up the multiplayer Unreal demo. You can kind of see how that works. Ryan Lilly has a good tutorial series on it. So I'll post that for you guys like that. Of course, if you're using the first-person template, you don't actually have a mannequin, right? You're a floating gun. So if you're going to be doing multiplayer, you might want to start off with one of the other templates. There is a multiplayer shooter demo that will actually have people's bodies and animations already done for you. I would start with that. Shooter? You're not gonna... No? Nothing? Not work? It's a problem with installing so many things. No, I'll have to find it for you. Shooter helper. There is a multiplayer shooter demo somewhere in here, and I would start with that. That's what happens if you download too much free stuff. That's important. Huh. Yeah, I'm not seeing it on here. But you can find it. I'd start with that if you're going to do multiplayer. Share the link for the AI, the perception thing. Didn't I share it? No, I didn't. Okay. UE4 perception system. There. There. Okay. So, yeah. All right. So yeah, so that's the beauty of edge detection. It's similar to how the human brain works. The human brain starts with raw input flooding in from your optic nerve, goes underneath the brain to the back of the visual cortex there, and you start off with just raw image data, and then there's like multiple levels of hierarchy in your visual cortex. And so it does things like it finds lines, and then it groups the lines together into shapes. Then it recognizes these shapes. Your memory system's connected to it, so you can just like instantly recognize the stop sign, because the stop sign is a red thing with this line here and this line here. And so even if you see it from an angle and things like that, you'll still recognize it. Or if it's upside down, you still recognize it. And there's all sorts of really interesting things on how that works. But basically, finding a line is sort of the starting, basis for human perception. And a lot of that's used in AI perception and autonomous vehicles as well. Okay. So yeah, that's Wavelet. This assignment due 2020. Yeah. You got till next Friday to do both of them. And so I would like come up with a timeline, like project management wise. Somebody's gonna need to get cracking like soon on it. We talked about animations last semester, right? Like we talked about I don't know if you were in my class last semester, depending on which one you are. So yeah, maybe starting with a third-person template, but I'd probably start with a multiplayer shooter template, then add AI to it. The nav mesh, I'll give you a link on the nav mesh stuff as well. Let's see. Oh, this one. This one doesn't work, I don't think. Yeah, maybe it does. I think this one actually doesn't work. Yeah, well, the content examples does do it. Yeah, behavior trees is. Yeah, that's really important. That's how you program AI. So you basically have like different scenarios and things like that. Where is the nav mesh? Nav mesh. It only appears here. Interesting. Well, there's not a whole lot of. It's surprising that it. Doesn't have more. Let's see here. Creating, placing volumes. Yeah, very little on the nav mesh. I think Ryan Laley has one on. I think he's got a demo on how to do AI with that as well. Yeah, there you go. So post that for you guys as well. Take a look at that. And then if there's anything you want me to lecture on, just let me know. So for animations, you need to have speeds way up. This thing shrunk down again too. The scaling is so weird on this. So animations are interesting. So if you've got a mannequin, okay, and the mannequin can be replaced with really any skeletal mesh. A skeletal mesh is what's the best way of putting this? A normal mesh would be something like a chair. It's just all one group of triangles and things like that. A skeletal mesh has bones. You can think of it that way. And joints. And so there's independently moving parts on the skeletal mesh. Whereas a cube doesn't. It's just, it all moves together. And so if you were to double click on the mannequin, you would see that there's actually a whole bone structure to it. And so the start of a skeleton is the root, and depending on which rigging system you use, it's either the pelvis, like your tailbone, or it's the floor. And you can actually have animations. Your animations are actually targeted at a skeleton, not a specific character in the game. So, for example, if you've got I don't know, Shrek, and you've got like Prince, what was the guy's name? Farquhar. They both share the same skeleton. They have a head and 2 arms and 2 legs and 3 bones in the spine. All right, there's the upper back, middle back, lower back. Or no, sorry, other way around. Because it goes up from the pelvis. Then you can actually have an idle animation where they're just kind of sitting there doing this. And it would work for both of them. So animations are actually targeted at specific skeletons. And your basic humanoid skeleton will work for most characters, right? As long as you don't like play with the scale too much, or make them too fat or too skinny or too tall or too short, it'll in general work pretty well. And preview animation. So there's all these different animations, and you can just preview it, and you can see the animations say move this bone at this keyframe, move this bone at this keyframe, and that's about all there is to it. Right. And so you can physics aspects control things like mass and like when they ragdoll, like how they behave. You can have a constraint set on it so that yeah, there's a constraint there, and so it kind of control so your arm doesn't like flop behind your body, which would be really weird looking. You don't need to worry about those too much. The skeleton itself is here, and so a skeleton attaches to a skeleton mesh, and then an animation attaches to the skeleton mesh. That's kind of the hierarchy that this stuff takes. And let's see, up here on the right hand side, which is hidden by my face, let's see here, webcam, hide, there we go. So on the right hand side here, you can see skeleton, attach a mesh, attach an animation, and then physics is attached to that, and you can have a blueprint as well. And so you can actually click back and forth between the 3 things. So the mesh is actually what is drawn, like these triangles here, is the mesh, and this is the mesh. All these triangles here. The skeleton is actually the important thing, and so you can have the same skeleton on different meshes. So you can have like a Shrek with the same skeleton as Prince Farquhar, and then if you do that, the same animation will work on both Shrek and Prince Farquhar because the animation moves the skeleton. It doesn't move the mesh. It doesn't care if the skin's white or blue or whatever. So you can add attachment points to a skeleton. So if you and if your people are different, you can retarget the meshes and kind of adjust for somebody being really short or tall or fat or something like that. So in general, I'll just recommend just using zombies that are the same as the humans. Then you can use all the set of animations that are the same. That could be found in the animation starter pack. Okay, so the animation starter pack has a bunch of stuff like that, and that's pretty good. And then there's also the mobile mannequin. So that gives you a new mannequin to play with. But in general, mannequins look kind of dumb. So you should find not a mannequin. You should find there are Paragon assets. Man, I got a lot of stuff here. And so the Paragon assets give you mannequins that actually look like people. They're gargantuan, by the way. These assets are like really, really, really big. But they are, actual, they're rigged. They have a skeleton on them and stuff like that. Hopefully they use the same bone names. If they don't, then you have to do an extra step to kind of rename the bone names. But basically, you import the skeletal mesh, and then you can animate them just like you animate anything else. It's actually pretty straightforward. You just have a different mesh for them. So you would import a skeletal mesh and attach a skeleton to them, and then the same animations that work on this mannequin here will work on that animation over there. So you can play with the animations if you want. You can actually create zones on a skeleton so you can have the lower half moving independently from the upper half. But what I was going to show you is sockets, and so you can actually attach sockets to a skeleton so that you can have it hold a gun or something like that. So right here, you can see I attached a gun socket. And so what I did was, what is it attached to? It is attached to, who is it attached to? Is it attached to the hand, I think? Maybe. It might be attached to, I think it's attached. Yeah, it's attached to the hand. Okay, so wherever the guy's hand moves, this socket moves as well. And I've got a ring slot here, so the ring slot is attached to the middle finger. And so wherever the middle finger moves, that slot moves as well. And the benefit of adding slots like that, let me show you how to do that. And you can add sockets either to a mesh or to a skeleton. In general, probably the skeleton's better because then you can swap out the mannequin. So I've got a hat slot here. And so what you do is you just right-click on any of these bones and choose Add Socket. And then you just kind of move the socket around. So like if you want a hat slot, just put it up right there. And that's it. And then and then if we preview the animation, let's just do a jog or something. That's not a jog. Preview mesh, not preview mesh, preview animation, jog. If you do that, then you'll see the ring slot comes along with the ring finger, the gun socket right there comes along with the hand, and so if you put a gun in there, it'll actually look like he's holding a gun. It's kind of nice. And then the hat slot, whatever you put in the hat slot, we'll see how it's attached to the head. Pretty easy stuff. So don't want to say that necessarily. And so this guy here has been attached to the detach it. So I could come here and say attach to whoever this guy is. Who's this guy? Preacher Man. Okay. So come in here, right click, choose attach to Preacher Man, and I can choose what socket to attach it to. Gun socket, like that. And then when I hit play, do you see that? The thing comes along with it. So if you want to attach something to somebody's head, why is this thing all zoomed out? Ancient treasures, that's cool. All right, meshes. So like, let's say I want to attach something to that guy's head there. I can take out a helmet. I'm going to move it in place. That. And if I hit play right now without attaching it, you'll see this guy here is moving, but the helmet's not moving with it, right? So you need to attach it. Okay. And why does it keep jumping back here? Oh, that's the player start, really? Okay, that's weird. And so what I need to do is I need to right click on it and choose attach to. Who's this guy? Dude. His name is Dude. All right, cool. So I'm going to right click on this guy and choose attach to. I'm just going to search for Dude. What happened? Attachments failed. Dismiss. Cannot attach an actor to itself. Well, that's fair. Cannot attach static actor. Oh, it's static. That's why. So I put this helmet out, but I need to make it movable. There we go. All right, cool. All right, so you get attached to dude here, and I'm going to attach you to the hat slot there, and then I'm just going to slide you into place. That. I play, then you'll see as the guy looks around, there's a helmet attachment. So pretty simple. Needs resize. Yeah, no, I'm not super concerned about it. Oh yeah, this chair just vibrates up and down randomly. And over here we got a glass with a strong Fresnel look on it, so it's got a very high index of refraction on it. That would be something that would look pretty neat with RTX, I think. You can see it's kind of working. Okay. This guy has a flower on his head. This guy's got a helmet. Picking up items. Okay. So that's enough, I think, for today. So, animations. That was animations in a nutshell. Is not all of you had me last semester. So basically, you can import, those Paragon assets or whatever. And let's see, who do I not want to save? First person, skeleton, I don't want to save you. The map, I do want to save. Okay. So if you import Paragon assets, just be warned, they're gonna be big. They're, let's see, let's add her to the project, why not? So what was that, spring 2021, add to project. Just one character is 1.5 gigs for a single person. It's it's quite ridiculous. And once you import it, then your game bogs down as it tries dealing with 1.5 gigs of data. It's like, my lord, dude. Yeah, game development is not a what is it? It's doing this thing again. It's bugging out. Good job, Unreal Launcher. That's high quality stuff right there. Okay, so yeah, when you import it too, just be aware that it's gonna slow down. I think the assets come with animations as well, and so if the skeleton doesn't match the one for the mannequins, then you can create a what's called a rig that will convert between the two of them, so you can use the animations for either. Or you can just use her animations because she comes to the whole set as well. And so what you can do is maybe have your zombies be one of these things instead of just mannequins. Mannequins are kind of lame. Like maybe, I don't know, like this guy, or that could be a good. These could be good monsters here. Yeah. And they've got a whole set of animations and things like that. And then you can, whoever does the AI, you can trigger different animations, like when you walk and shoot and things like that, and make it look pretty cool. So yeah, so that was our lesson for today. Real brief introduction to how animations work. You got a skeleton, you got a skeletal mesh, which is how it looks. Skeleton is how all the bones connect together. The fingers are attached to the wrist. The wrist is attached to the lower arm. The lower arm is attached to the elbow. The elbow is attached to the upper arm. The upper arm is attached to the shoulder. The shoulder is attached to the clavicle. The clavicle is attached to the upper back, upper back's attached to middle back's attached to lower back, and your pelvis is the root. And so if I move, watch, if I move my waist around, everything moves. But if I move my wrist, not everything moves, right? Only the things that are the children of it move. Okay? So if I move this joint here, all the children of it move. If I move this joint here, all the children of it move. If I move the elbow, all the children of it move. Nothing else, right? If I move my neck, the head doesn't move. That's what that hierarchy that we saw is. It's like what's attached to what. And so if this thing moves, what needs to come along for the ride? And in general, if you're using a human, they all have the same general layout, right? Everyone's got a shoulder and an elbow and a wrist and things like that. However, not everybody names the bones the same way. And so if you look at the Mixamo assets, these guys here, they've got a ton of animations. Mixamo, I think, was a free website. I don't know if it's still around, from Adobe, I think, if I'm remembering correctly. And their bones are named something different. So their spine 2 is the other one's spine 1 and things like that. So you have to kind of go through a retargeting step to tell Unreal what this is with this. And then you can share animations between them. It's a little annoying. You have to go through all the bones in the human body. It's just, it's 5 minutes of your life wasted. But, it's more assets that you can use. So that is also free, I believe. Ooh, 4.10. So, yeah, tons of stuff that way. So that's our lesson. And do you need to place monsters on the map and activate them in a timely manner? Can they generate, like, every 10 seconds to say monster is born? You can set up a timer, and we can talk about that tomorrow if you want a timer. Just remind me if you want to learn how to do that, how to spawn things periodically. Yeah, I can go over that tomorrow. We're basically out of time for today. But I hope you learned something about animations. Whichever one of the three of you are going to be doing the animations, that's your 15-minute intro to the subject. And I like your ideas. I think they're doable. Just make sure you get started now. It's a tendency for people to wait to the last minute. And you've got 2 projects, right? So if you wait to the last minute on one of them, you're definitely not going to finish the other. So this is definitely an option for you to demonstrate your project management skills. I'm not going to give you, maybe I'll give you like one more like one-off programming assignment. So it's kind of like one other thing I want to do with you guys on the server. But yeah, and some of your daily requirements will just be check-ins, like show me that you've done work today, because it's a really easy thing when something's done in 2 weeks to just not do anything each day. And so your daily check-in for tomorrow will be, I don't know, somebody getting the Perforce server up. That's it. And all 3 of you get credit. Okay? I'm going to create a group for the 3 of you, and you will all be graded collectively on this. Okay? So maybe for tomorrow only one of you needs to set up the Perforce server. That's fine, but you'll get the 10 points that way. Okay? I'd like to see that done by tomorrow, because that is absolutely the first thing that has to happen. And that's somebody at my front door, so that's a good place to end it as well. Pepe with the Holy Cross. Yeah, that's only one thing. It's only one thing. Just one thing for tomorrow. All right, I'll see you.